And let's make the period rate, market rate divided by 12. So if mortgage rates go up 8%, if you're keeping this mortgage in your books, yeah, you lent $100,000, but that mortgage is now worth only slightly above $90,000. If mortgage rates went down to 6, you made money. In a sense, keeping a mortgage in your books creates interest rates. This is one of the reasons why, remember, you have to fund these mortgages, okay? You can either borrow at short-term rates, which run up, and lose money that way, or you can sell the mortgage and get rid of it, or lose money that way. Either way, you lose money. I could calculate duration directly, but I'm going to end up writing a code. First, let's calculate Macaulay duration, which is some product of the periods with the PV, and I'm going to divide that by the PV of payments. Since periods are in months, that Macaulay duration is in terms of months. If you want to convert that to years, 1 over 12 times that. So 30-year mortgage has roughly a duration of 11 years. At similar rates, a 30-year bond. Let's make these things equal. So at par, 10-15. Oh, let's also calculate the financial duration. Macaulay divided by 1 plus the period rates. Let me get so it has a financial duration of 9, a 30-year bond with a yield to maturity of 7 and coupon rate of 7. And let's make it 12 just to make it the same. It has about 12 and a half years worth of financial duration. Or 2, or a bit higher. So financial duration of a bond is higher than financial duration of a, from now on, I'm just going to say duration. If I don't say anything, that refers to financial duration. That kind of makes sense because you make the payments on average earlier on a mortgage compared to a bond. A bond has a balloon payment, if you think about it. Now let's write down a code that calculates value of a given stream of cash flows, but they do not have to be even. Okay? You have to provide number of periods and the payment. Let's go ahead and go to developers. Let's go to the bottom. Actually, it doesn't matter where you write it. I'm going to write it here. Excel doesn't execute them in order as long as they're there. So let's call this function PV cash flows. Again, that's the name I'd like to give. And there's going to be basically two arguments. I rate, three arguments. That's for interest rate. I flows. I'm going to declare that as a range object. Okay. A range is basically an area selected on the worksheet, right? And it could also have multiple areas, which I'm not going to handle for this class, but it is not too difficult to adjust. And the third argument, and I want to do this to show you how to use optional arguments. Optional ifrec equals 1 as double. Let me see. I thought I handled right. Just to give a default value. Sometimes I forget, I just look it up. Oh, okay. As double equals 1. Actually, as integer equals 1. I don't want no stinking non-integer compounding frequency. It's basically how many times you make a payment in a given year, or how many periods are there in a given year. The beauty of this, if you're doing annual, you can completely leave that out, and code is going to assume that it's 1. You know, when you call the function, all you have to do is give the interest rate and the range that has the cash flow, and VBA assumes that your ifrec equals 1. Sometimes it's a little bit cleaner. This function calculates present value of a set of cash flows, maybe irregular, and inputs are I rate equals discount rate and APR convention. What is that? I flows, a contiguous. I'm going to set it up for that, but it's not too difficult. Range of cells in Excel. That has 2 columns. The first column as number of periods. In the second column as cash flow. And IFRAC default equals 1. Optional number of periods in a year. You probably guessed that I could have written this function when input is in rows